Okay, this is a type error question, and they often have something strange about them. They just look different to other questions, and a lot of students are put off by them. So let's just understand it first. There's a giant box, and by that we mean infinitely big, of sweets, and the box says on it that 1/3 of them are milk chocolate. Okay, you say, well, I don't really believe what it says on the box, so I'm going to test that claim, and I'm going to do it by taking a sample. I foolishly take a small sample of only 9, and this is what is unusual about a type error question. Is it says something like this: I'm going to reject the claim if I see 5 or more milk chocolates in my sample. So normally you would say, what's the significance level of this test? And I'll work out in what situation you'll reject it. So this is sort of set up the other way around. They've told us what the rejection region is. Now remember that a type 1 error is when we reject H0 even though it's true. So we are definitely going to assume in this question that there are a 1/3 of this giant population of sweets. We're going to assume that 1/3 of them are milk chocolates, exactly 1/3. Now, if we took a sample of 9, what are the chances that we would get 5 or more milk chocolates? Because if we do, we're going to have to reject that claim, even though we know it's true. So have a look at these two questions. What is the probability of a type 1 error? What is the significance level of this test? Now, this is the same question. Significance level is the amount of doubt you're prepared to go with. It's the opposite of how much confidence you have in your answer. So typically it's 5% or 10%. If you say a significance level is 10%, then you can say, I have with 90% confidence, I can reject the null hypothesis. Okay, so we'll never be, ever be at 100. So the probability of a type 1 error cannot be 0. There's always a chance of an error here because ultimately we cannot count the whole population. So we'll never know if there are actually 1/3. What we could do is take a huge sample and really drum up the level of confidence we have. So this is a hypothesis test, and you have to identify it. Now, what we're talking about here is a proportion of a population. We're saying that 1/3 of this population is milk chocolate, and it is called a hypothesis test for proportion. And a lot of students will not really recognize that, but I hope you can spot what type of hypothesis test it is anyway, because we're taking a sample of size 9, fixed number, and there's a yes, no. Is it milk or not milk? So it's quite clearly a binomial. So my null hypothesis is must have an equal sign in it. So even though the claim of the test is normally the alternative, it doesn't have to be. The null hypothesis must have an equal sign in it. This is the proportion of the population. Okay, it should be a Greek letter, but we traditionally don't use the Greek letter for P. So, but you should be thinking, I'm talking about the null hypothesis being 1/3 of all the sweets in the population are milk. Now, one habit to get into is if you're in a binomial or Poisson or a normal or T, you should write that population down, that distribution down as part of the null hypothesis, but definitely when you're in binomial or Poisson. So the null hypothesis is saying, I would expect the sample to be distributed in this way. I know I'm taking a sample of size 9, and there's a 1/3 chance that each sweet is a milk, because that's the null hypothesis. So this is part of the null hypothesis, that is the null hypothesis together. The alternative is greater than, because although the opposite of the box saying it's 1/3 milk should be it's not 1/3 milk, not equal to, the way that this person has decided to set up the hypothesis test is clearly one-tailed. I will reject the claim if I see 5 or more milk chocolates. And so we must set it up like that. Now, the best understanding of a type 1 error is this formula here. Type 1 error is a type 1 error is being in the rejection region even though H naught is true. Now, the rejection region is given in this question, so it makes it a bit easier. The rejection region is x is greater than or equal to 5. So what is the probability of being in that if we are under this distribution here? Well, that's a simple thing to do. Let's just do it on the calculator. And so we set it up and run it. We can see what we're looking at here is the rejection region, the shaded bit, and its size is 14.5%. So the significance level and the probability of a type 1 error is 14.5%.